Hello everyone, we're standing here today at the Sustainable Aviation Futures in Amsterdam. My name is Johann Wiebe, I'm the director of the Hydrogen Standard, and with me here today is Graham Provost from CORYS. Welcome, Graham.
Thank you.
First off, Graham, you guys are also, CORYS is a sponsor, much appreciated, and thank you for that.
You're welcome.
So to starting off then, maybe you can tell us a little bit about your job within CORYS, and then we would love to hear a little bit about what CORYS does.
Sure thing. So my job at CORYS, I'm Vice President responsible for strategy and business development for the process industries in the Americas. And what CORYS does is build dynamic simulation for all different types of facilities in the process industries for oil, gas, chemical, really any industrial process. We make dynamic simulators for those. And then we also have verticals in nuclear power, where we do a lot of nuclear power simulation around the world, and then also transportation, primarily rail simulation. So we have a large market share for everything, for rail simulation, and handle everything from subways to high-speed rail to freight.
There's a lot of simulation there, and could you tell us a little bit what the relevancy of simulation is in all those industries?
Right, sure thing. So, and I'll focus, I think, on SAF and what we do in this particular arena. For with dynamic simulation, it can be used for a number of different things. So, it's used in many cases for plant design and engineering. We'll take information from process licensors and also from end users about their facilities, whether it's a new construction SAF project or a SAF conversion project. And we build a dynamic model that's used on the front end for, as I said, engineering design, but then also for operator training and familiarization prior to the controls being developed. Then once the controls are developed, we connect our simulators to the controls and we validate the plant controls by connecting to them, and then have the operators go through training programs and learn exactly how their facility is designed to operate, in addition to validating and tuning and optimizing the control approach for the facility.
So what is really sort of the objectives that these models try to achieve? What is it really contributing to sort of the facilities that are maybe in operation and are maybe also being developed?
Right. So operational excellence for facilities that are already in operation, and for facilities that are being developed, it's about speeding the time to commercialization and ensuring flawless startup, while at the same time making sure that the staff is trained and ready to operate the plant on day one.
What do you sort of see in terms of the challenges maybe in the industry, also in relation to SAF, from your perspective?
Right, so there's a lot of variability in the industry right now, and I think those are the challenges. Everybody's trying to find what the right answer is, and quite frankly, there's been a lot of government research and private research, and that's been done over the course of the last really 10 to 20 years. I don't think that we've really still found exactly what the answer is, and I think that the truth of the matter is, in that particular case, is because there's so much variability around the world.
Variability in what sense do you mean?
Variability in feedstock, variability in how you collect it, variability in weather. A wet feedstock is not as easy to make SAF out of as one that is dry and densified, things like that. So it's just a question of supply chain and getting it from A to B, and then also making sure that it's homogeneous and can be fed into the technology that actually makes it.
Okay, Graham, can you tell us a little bit about the Brownfield and the Greenfield projects and what you guys can offer there?
Yeah, absolutely. So in Brownfield or SAF conversion projects, we focus primarily on training the operations staff and making sure that there's a high-fidelity dynamic simulator that allows them to speed the time to commercialization for that SAF conversion project, while making sure that operators are fully ready to operate the plant as soon as it's ready to be operated. And then for Greenfield, or just straight up new construction projects, we're usually attached to those projects for much, much longer. So with those particular types of projects, we're involved often in front-end engineering design. So we help the design company or the EPC, and in some cases the process licensor, to design how the process should work by using a dynamic simulator and modeling that particular facility or their conceptual design. We put that together, and then we, within our software, we have our own controls package where we can emulate the controls in terms of how we think that it should be operated, and we'll work with that organization's engineers to help to form a control control strategy prior to even having a controls company developing it. Then once the controls are actually developed, we connect it to our simulator, remove our controls, and now we're validating and tuning and optimizing the distributed control system or PLCs or however it's being operated. And then that same tool is then used for operator training by developing a training program long term.
Fascinating stuff. Graham, finally then, what are your thoughts on the Sustainable Aviation Futures Congress so far?
I've had a great time. This is a well-run conference, and it's a pleasure to be here.
Thank you very much, Graham Provost from CORYS.